an explosive. I'll project with a speed u at an angle theta. Somewhere at highest point, it is going to explode. It is going to explode here. So one of the fragment, if it moves in this direction, here explosion occurred. Okay, due to explosion, two fragments have come. So what about the other fragment? How it should move? It occurred at highest point. The center of mass will continue as if there is no explosion occurred. Am I right? No. There is a path of center of mass. If one of the fragment moves like this, what about the other fragment? How it should move? Momentum should be considered. The other fragment you cannot put horizontal. The other fragment should have velocity in this direction. If this is theta 2, this theta 1. At highest point, what is the velocity mu cos theta? Just before explosion, it will have horizontal velocity how much? U cos theta. Then what are the equations you are going to write? Net external force on the system along x-axis 0. So momentum is conserved. So initial momentum mu cos theta, mv1 cos theta 1, m2 v2 sin theta 2. Along y-axis also, the net momentum is conserved equal to 0. So you can write conservation of linear momentum. So initial momentum 0, final momentum m1 v1 sin theta 1. Like this, you can apply conservation of linear momentum. But if one fragment is having velocity upward, the other fragment cannot have horizontal velocity because momentum has to be conserved. So the second fragment should move in a plane. The first case, here explosion occurs. Explosion occurs at highest point. Okay, there's the one condition. Then, okay, now during explosion also some energy will be released here. So if I put it mu, what is energy released? M. Initial kinetic energy just before explosion, plus some energy will be released, E0. So what is E0? E0 is, we'll write it here, E0 is energy released during explosion. Okay, this energy released, it can be in many forms. If the total energy converted into fragments means what you are going to do, you are going to write equation like this: mv1 square by 2 m2 v2 square by 2. So here what happened, the whole energy is converted into kinetic energy of the energy released is converted into kinetic energy of fragments here. It can happen half of the energy is converted into, half of the energy released is converted into kinetic energy of fragments. Remaining of will be converted into sound. I think in Deepavali crackers, when you throw cracker in air, in mid-air explosion will occur, no? The cracker will get blast. So what actually happens, we'll get a sound also, no? And also we'll get lighting also, some crackers. Then what happened there? The energy released, a part will be converted into sound, a part will be converted into fire, the remaining will be converted into kinetic energy of fragments. It all depends upon, if I put a condition, the whole energy released is converted into kinetic energy of fragments means you should write equation like this. Half of the energy released converted into kinetic energy of fragments means you should write E0 by 2. Where do remaining of gone? Can be sound, can be fire, whatever be that. So there is no rule that the whole energy should be converted into kinetic energy of fragments. If I say that half of the energy released is converted into kinetic energy of fragments means you should write E0 by 2. I'll put that by 2. So what is the energy released during explosion? So what I'll put a condition is that let half of energy released during explosion is converted into kinetic energy of fragments. Then I'm able to write this off. Otherwise, I should not write off.
Sir, m2 v2 cos theta 2 should come. Sir.
Yes, sir.
Oh, kinetic energy, how it will have the direction, my dear.
Sir, in mu, in delta fx equal to 0, one equation you wrote right, sir. There, sir.
m2 v2 cos theta 2.
Oh, here, momentum.
Yes,
Okay, yeah, fine. Yeah, thank you.
Sir, and delta fy equal to 0, how did you do, sir? Gravity is acting, no, sir. External force.
Explosion will take for 1 hour. Deepavali cracker not burnt.
Sir, at that instant you are doing, sir.
Yeah.
Okay, sir.
What is the explosion? Will be fraction of time, no?
Yes, sir.
And what is the change in momentum due to gravity? Nothing will be there. The internal forces will be very much greater than gravity. So therefore, the change in momentum, what all occurs, will be due to internal forces, not due to gravity.
Yes, sir.
Okay, now, sir, these are the conditions they'll put it. If there is no energy released,